All right, take a moment to look at this shape. Disregard the fact that it's not perfect, okay? We're assuming that these are perfect circles. These two small circles are identical in size. And at this point right in the middle is your center points. I want to find the area of the shaded region. The shaded region is all this black stuff here, okay? In order to find the area of the shaded region, it looks like we're going to have to find the area of the big circle and then take out the two areas of these smaller circles, okay? Well, how do we go about doing that? First, we have to analyze our figure, okay? So I know that I have to find the area of the, in order to find the area of the shaded region, I have to find the area of the big circle, that's my area of the big, and then subtract the areas of the two smaller circles. Well, I can find the area of the two smaller circles because I have everything that I need. I have the radius length of these two small circles, so I can do that. But I do need to find the area of the bigger circle. Okay, so let's analyze it for a second. All radius lengths are the same of a given circle. So since this radius length is 3 inches, we know that this radius length is also 3 inches. And this radius length is also 3 inches as well. Well, we just found the diameter. If this is 3 and this is 3, the diameter of this small circle is 6 inches. Now this also happens to be the distance from the center point of the large circle to a point on the large circle, which means that this 6 inches is the radius length of the large circle. So now we can find the area of the large circle. So let's go ahead and do this. Now we have all the information that we need, so we're going to find the area of the shaded region. And we're going to break it down into smaller parts. Okay? So I need to find the area of the big and the area of the two small. So what I'm going to do is I'm going to write on my work on this side. I'm going to start out with the area of the big. That's the area of the big circles, this circle here. Okay? So we know that area is equal to pi times the radius squared. So that means I'm going to use the pi button on my calculator just to cut time out. So it's pi times the radius squared. The radius of the large circle is 6 inches. So it's 6 inches squared. So now on your calculator, I'm just going to multiply them. So we're going to multiply pi times, what was it, 6 squared, which we know is 36. Pi times 6 squared equals 113. I'm going to round to the nearest tenth spot, and 1/10. And that is inches squared. Okay, and I'm going to box this in blue. That's our big. Now I'm going to write in red the area of the smaller circles. So the area of the two small is equal to 2 times the area of 1. So 2 times pi r squared. I'm multiplying it by 2 because we have 2 identical circles. Okay, so that is equal to 2 times pi times the radius squared. The radius we were given already is 3. So 3 squared. So now I'm going to do that on my calculator. So I'm going to take 2, I'm going to put parentheses in. So 2 times, and then pi 3 squared. I don't need it in my parentheses, but I'm just going to because it looks better. Okay? And that's equal to 56 and 5/10. All right, now we have everything that we need in order to solve. We have the area of the big and the area of the small. And we know in order to find the area of the shaded, we simply take the area of the big and subtract the area of the two smaller. Okay, so let's just plug our values in now. So the area of the shaded is equal to the area of the big, that's 113 inches squared, 1/10 inches squared, minus 56 5 inches squared. So that means the area of the shaded is equal to 113 1/10 minus 56 5/10, which is equal to 56 6/10 inches squared. Notice how I liked to write. I wrote my work off to the side and tried to keep it as neat as possible.